Welcome to online learning by Professor Tanuja Date from Electrical Engineering Department, K.K. Institute of Engineering Education and Research, Nasik. Let us learn today power method for eigenvalues. Now these eigenvalues are important for understanding the stability of any given system. Once we obtain the characteristic equation, we usually can find eigenvalues and then we can find out the corresponding eigenvector and we can comment on the stability of the system. A numerical method for finding eigenvalue of n by n matrix is for finding largest eigenvalue. Assume that A is a characteristic matrix having n by n size so that n distinct eigenvalues like lambda 1, lambda 2 to lambda n can be found out. Further, assume that among all these eigenvalues, lambda 1 is the largest among all, and so if lambda 1 is greater than lambda 2 and so on greater than up to lambda n, lambda 1 is called the dominant eigenvalue of A. Let us assume v1, v2, vn to be the corresponding non-zero eigenvectors to the eigenvalues lambda 1 to lambda n. The eigenvectors corresponding to lambda 1 are called dominant eigenvectors of A, like v1. The power method for finding dominating eigenvalue. If x0 is a non-zero vector such that x0 has a maximum value so that each of the components in the vector are between -1 and 1. Now for defining successive approximations, we start with x0 value, multiply it with the matrix A and obtain x1. So this is an iterative process. Then x2 can be obtained by multiplying A with x1 which we have obtained, or it can be also written as A into A x raised to 0 like A square x0 and so on. If we keep on calculating x up to n iterations, we finally obtain A raised to n x raised to 0 in the form of multiplication of A matrix with the previously calculated x vector. The vectors x raised to n are approximation to corresponding eigenvector of the dominant eigenvalue when approximatively scaled. Now the theorem says that if x is an eigenvector of A, then the eigenvalue lambda corresponding to eigenvector can be calculated as Ax, which is the multiplication, into x divided by x into x. Now this formula which gives the dominant eigenvalue is called as Rayleigh quotient. Suppose that x is the eigenvector of A, then Ax is equal to lambda x is the corresponding eigenvalue of A. This can be calculated by using this expression which is called as Rayleigh quotient. So first we need to obtain x value Ax into x and then we can obtain lambda which is the dominant eigenvalue for the corresponding dominant eigenvector. This is the example. To explain this method, find the dominant eigenvalue of the matrix 3, 5, 3, 1. Now let us take x0 as 0.5, 0.5 as the initial approximation. To begin with, we multiply it with A and we obtain 3 into 0.5 plus 5 into 0.5 which makes it 4. 3 into 0.5, 1 into 0.5 makes it 2. So x1 becomes 4, 2. Using this as for the next calculation, we multiply it again by A and we obtain the next value x2 as 22, 14. So on, we keep on doing it for number of iterations and finally we obtain this value as x5. Now suppose we have decided to take up to 5 iterations. We can now calculate eigenvector approximations as by taking 2 out, we get x1 as 2, 1, x2 as 14 taken out, we get 1.571 and so on, and x5 we get 2912 taken out as 1.671. So 1.671 could be taken as the corresponding eigenvector. When we multiply this with A, we get 10.01 and 6.01. The most dominant eigenvalue can be calculated now by considering this calculation. Ax5 multiplied by x5 divided by x5 into x5. Once we calculate this, we get the approximate value to be 5.996, which can be approximated to 6, which appears to be the most dominant eigenvalue as the largest eigenvalue for this vector, and corresponding vector would be 1.671, which will be taken as largest eigenvector. Alternately, instead of using this type of calculation, we can also use the power method for getting the largest eigenvalue and eigenvector, where the eigenvector value will be always less than or equal to 1 all the time. Now let us see this second method as in this example. For a equal to 7997 with x0 given to be 1 and 0, because now the condition is this should not be greater than 1, we are taking this as the initial approximation for finding largest eigenvalue and the corresponding vector. If we start calculating this again, ax0 becomes 79. Now this step is same as the previous method, but what we do now to maintain this vector as less than 1 or maximum equal to 1, we pick up the largest value of these two values and divide. So we take 9 out and we divide 7 by 9 becomes 0.78 and this becomes 1. So now for the next calculation, 0.781 becomes the next approximation, which we multiply by a again and calculate this. Now when we get this calculation, we can extract 14.44 to be the largest value and divided, we get the vector converted as 1 and 0.97 and so on. If you have understood this method, you can keep on calculating this by using the previously calculated vector here for multiplication with a, extract the largest value outside to convert the vector into quantities which will have value at the most 1. So hence we get a5, x5 as 15.998 multiplied by 1.0999, where this 15.998 becomes our largest eigenvalue, whereas this corresponding vector stands to be the eigenvector corresponding to this eigenvalue. Ideally, this value should have been 16 and the corresponding vector could have been 1, 1. So these are two ways of calculating largest or most dominant eigenvalue and the corresponding eigenvectors. You can choose both the methods, whichever you feel comfortable and easy, but you can keep practicing both the methods. So these are the 2-3 problems which I have given as homework. Find the dominant eigenvalue and corresponding eigenvectors for the matrix. In each problem, I have given different A matrix with initial guesses. Second problem, again you have to find dominant values, eigenvalues for the A matrix and this initial guess. Same is for third problem. Solve these problems with different methods for practice and compare the number of iterations to find the results and accuracy of each method. So if you have understood this, the only way to learn this, repeat this presentation and keep on solving the problems. Take a piece of paper and keep on solving same problem by both methods. Compare. If you are calculating for same number of iterations, you can compare the result accuracy by seeing the closest value to which it is converging. Happy learning. Thank you.